timing does matter in every aspect of our life. People really control their own circadian orchestra by just deciding when to eat and when to stop eating. Light is still the primary driver for our unconscious or subconscious decision to eat. So that's why we have to control both light and food. All the labs that work on metabolism, obesity, diabetes, and all these bad diseases that happen to us triggered my thinking, how much of the disease that we see is due to the mistiming of the diet?
What does it look like to follow time-restricted eating, and why does it matter?
Well, the thing is,
Dr. Panda, we are so excited to have you here. Thank you so much for traveling all this way to be here.
I'm excited to be here too.
We're going to start with something a little bit fun. We're going to do a rapid fire set of questions. You can only answer true or false, and then we'll dig into the details over the next 45 minutes or so. True or false? The time of day you eat has no effect on your metabolism or long-term health. Okay, you knew that was an easy one. Hey, true or false? Exposure to blue light at night can disrupt your ability to fall asleep.
True.
True or false? Hundreds of medications could be more effective if taken at specific times of day.
True.
True or false? Does restricting eating to an 8 to 12 hour window show benefits for both weight control and inflammation?
True.
And then last one, true or false? All cells in your body run on the same clock, regardless of external light cues.
False.
All right, you looked like you had more to say there. What was the hesitation?
Well, the thing is, external timing cue mostly and trends are part of the brain clock. But the rest of the body and rest of the brain, actually, they work on timing of food clock. So that's why you can have light driving part of your brain. And then if you eat at the wrong time, then the rest of the clock can be out of sync.
So let's jump off here, because I actually think this is one of the big contributions that your research has had to the field. And I think a lot of people, and Whoop certainly harps on this point, like circadian rhythm, sleep consistency. And I think most of our members really only appreciate circadian rhythm, sleep consistency. And your research is all about, there's a lot of different important behaviors. You've done fascinating research around physical activity and eating and how they relate to the circadian rhythm. So what do you mean that most of our clocks go off of food? What are people not understanding?
Yeah, so for a very, very long time, we thought that there is a master clock in the brain that makes us go to sleep and wake up. So the brain clock must be driving rhythms in the rest of the body. Actually, if you dial back to 1980s and early 90s, people thought there is only one clock that's only in the brain, and that clock ticks. And then towards the end of the last century, there was a big discovery that almost every cell in our body has its own clock. Even our skin cells has its own clock. So then the question became, well, if there are all these clocks all over the body, is there a master clock that actually, like a conductor of the orchestra that conducts this orchestra? And then people realized very quickly that it's the master circadian clock that's present in only 20,000 neurons at the base of the brain. And the technical term is suprachiasmatic nucleus. If you take out those 20,000 neurons, then the mice or rats, they have no sense of time of the day. So that's why people thought that that's the master clock, and that clock gets entrained by light and dark. And then there are a series of studies showing that this master clock in the brain actually regulates body temperature. So our core body temperature rises during daytime, falls at night, and that temperature rhythm is enough to synchronize all the peripheral clocks. And similarly, there are many other ideas. For example, cortisol, which is stress hormone, that can also synchronize clock. So all this stuff was kind of coming out of famous labs between, say, 2000 and 2010. And I had a curiosity, like, well, this is fine for a mouse, rat, or anyone, wild animal that's out there, because their sleep-wake cycle and eating fasting cycles are governed by nature. But we are the outlier. Humans are the true outlier, because we are the only species that controls fire and light. So we stay awake, and we truly have the freedom to eat at whatever time we want. So then we did a very simple experiment. And the experiment was to take even the night-eating mice. Mice are night eaters. Mm-hmm. So they stayed in light-dark cycle, just like day-night cycle. And instead of eating at nighttime, we fed them during daytime. It's almost like night shift workers who are working at night and sleeping during daytime. And then we asked if the brain controls all the clocks, then the timing of food should not matter because all the clocks will be the same, whether that day feeding or night feeding. To our surprise, we found that everything in the liver was tracking when the mice ate. And that was kind of a very big discovery at that time. A lot of people didn't believe it because right before that, there were publications showing that, well, there are some signals from brain that can still drive brain originating signal in the liver. But to our satisfaction, there are quite a few researchers from Europe and US. They validated our results. Not only that, we looked at only liver. They went on looking at all the organs and even part of the brain, even few millimeters away from the suprachiasmatic nucleus. And all those brain regions were tracking food. So then it became very clear that truly that's when the light bulb went off. And I said, I used to work on light, and then I thought light is the master controller of circadian rhythm, which I truly believe till now. But then the challenge is we don't have control over lighting. I did not choose what kind of light will be in the studio, what intensity, in which direction they will be falling. But I have the control over what I have in this glass of water, whether it's pure water or sugar water or whatever it is.
Promise it's pure.
So that's why we thought, well, then we can actually let people really control their circadian rhythm, because instead of the SCN being the passive conductor, they can be the conductor of their own circadian orchestra by just deciding when to eat and when to stop eating.
So in some ways, what you're saying is very exciting because, we're all kind of passive recipients of most of our light environment, right? When I'm home, I can control my light, certainly around evening and stuff like that. But I actually spend most of my waking hours here where it's above my pay grade.
So you go home.
Right. I go home and I can control my lights. Here I can't. Certainly can't control sunrise and sunset. But I do have a lot of control over my eating. So it's super fun to be having this conversation with you because I worked in one of these sleep labs that you're talking about starting in 2010 when we were told that the SCN was the master clock. And I worked with people who contributed to those findings. And I remember when, some of your research and the research you're talking about started to come out, and we were like, and I think that's what's so beautiful about science is that willingness to learn that we're wrong and to realize that the story is a lot more complicated. And in this way, more complicated in a really empowering way. We have more control than we realize. So you would agree that light is still important.
Oh, yeah.
Yeah. Okay, great. Not at all disputed. Is it the case that eating is more important than light in terms of entraining the circadian rhythm?
I won't go there because, it's like a tango, right? Both have to dance in synchrony. So you can't say that one dancer is more dominant than the other. And so I think the point is light still drives some of the eating behavior. Mm-hmm. So for example, if we have too much light at night, we stay awake. And then when we sleep less at night, then the next day morning, our control over food deteriorates. Sleep actually helps us to make decisions.
Yeah.
And there are a lot of decisions we make throughout the day. And some of the decisions are what to eat, when to eat, how much to eat, when to stop eating, what combinations to eat, with whom to eat, all the stuff. They go out the windows. And that way, light is still the primary driver for our unconscious or subconscious decision to eat.
So this is an interesting nuance. The light-dark cycle impacts sleep, and sleep impacts eating, and eating impacts our circadian rhythm. And so everything's impacting everything else because light behaviors and light exposure and therefore sleep impacts so much of what we choose to eat. Its ultimate effect on the circadian rhythm is sort of hard to isolate and greater.
Yeah. So that's why we have to control both light and food. So when it comes to controlling light, as we discussed, we have very little control over actual lighting. And even we don't have control over the specifications for the light bulb. Mm-hmm. We may choose different light bulbs, but actually we are at the mercy of the Department of Energy that figures out how much light each wattage of power should crank out. And those engineers, for their job, they have very minimal knowledge or appreciation of the quality of light. And also there is technological limitation. So as you know, most of our modern LED lights are mostly driven by 3 LEDs, RGBs, and it's impossible to simulate daylight with these 3 LEDs. And if you want more power from every watt, then you just crank up the blue LED. And most people who don't understand the color of the light or brightness of light, they want to buy the biggest, the brightest bulb for their buck. And when they buy that and then put it in their bedroom and living room, then actually they are making a mistake. But even if they dim down, they still have a lot of blue light. So I guess that's why food becomes an important story. But at the same time, we should not give up our attempt to control light.
So I want to tease apart 2 things that you're saying. One is we're buying the wrong light bulbs. For people listening, what light bulb should I have in my bedroom? And you don't need to get into a brand, but what should people be looking for in a sleep-friendly, circadian-friendly lighting choice?
So for most of us, when we go to any store that sells light bulbs come in mostly in 3 different flavors or colors. One is pretty bright and it has little tinge of blue. And that's the one that we most prefer during daytime. We feel a lot excited. And we're more also likely to buy that because we think that, this is a bright bulb and then I should buy it. And then at the other opposite spectrum is kind of the orange color light that mimics the old school candle light, and it's golden color. And then some people like that. And actually that's the light that has less blue light. So maybe that's the one may prefer for bedside table lamp or somewhere where you sleep. That's one choice, one layer of choice. And then the second layer of choice is your light switch. So most of us have flip switches at home. And so the next choice you can make is have dimmers so that you can also dim down the light if you need. So these are 2 different things that everybody can do to reduce their light exposure at night.
Right. So in terms of things that are good for your health, changing out your light bulbs, maybe adding a dimmer are pretty accessible home upgrades. If somebody does that, what would they expect to see happen to their sleep?
Well, so
if someone's listening and they're like, okay, it's better. Like, is it going to solve all my sleep problems? What's going to happen?
These are some of the elements in your toolbox to improve sleep. Just like, you cannot have only one screwdriver to fix all the screws in your house.
Oh, no.
So similarly, this is one. So people who have very bright light and they may not understand why they cannot sleep well or why they're so jazzed up even after dinner and after a long day. So they may benefit if they have very bright light. Dimming down light or having a orange shifted light bulb can help them to feel sleepy. And then in the extreme cases, if they want to filter out all the blue light, there are also blue filtering eyeglasses where you look cool because either you can choose to be yellow, orange, or even some people wear red.
We make our own, and we validated them in Whoop Labs, which is our clinical research lab downstairs. And then we did a sleep study. We did show that improved sleep architecture, reduced sleep onset latency, and improved recovery scores the next day. So big believer in the blue light blocking glasses. But it sounds like what you're saying is if you notice that you're feeling a little wired in the evening, this is a tool worth exploring, not necessarily going to make or break massive issues.
Yeah, I mean, you brought up this blue filtering glasses, and this is where, personal control over light. You can have a pair of blue filtering eyeglasses, and suppose you're traveling and you check into a hotel and that has the bad lighting, then yes, those are some of the cases where you can have complete control over your light.
I love the practical advice that you're giving here because, in my own home, I can change the light bulbs when I travel probably a bit extreme to bring light bulbs with me and change hotel room lights. You're traveling right now away from home. And so, blue light blocking glasses, something you can easily throw in your suitcase and bring with you. And so I love that tip. The other thing you were talking about, and I think people are going to really find this fascinating, so I want to make sure we do this area justice, but you talked a lot about eating. And you've pioneered a ton of fascinating research around time-restricted eating, which is this idea of sort of eating in alignment with your circadian clock. What are the principles here? What does it look like to follow time-restricted eating, and why does it matter?
Yeah, so the time-restricted eating, which is now popular as intermittent fasting, it started from our lab. And the idea was very simple because for many, many years, for decades, all the labs that work on metabolism, obesity, diabetes, and all these bad diseases that happen to us, they used to give mice fatty, sugary food, and then they would give the food and disappear for a few days, and then mice will have all the freedom to eat what, when, and how much they eat. And actually, this is a cool discovery from one of my Circadian colleagues, Joe Bass at Northwestern University. He just measured when mice actually eat this unhealthy food. And he found that mice, instead of eating most of their food at nighttime, they start to nibble more during daytime. So then during daytime, they're not fasting as much as they're supposed to, and at nighttime, they're still eating. So he published that, and then it kind of triggered my thinking. I thought, well, if it is so, how much of the disease that we see when our mice eat unhealthy food, gaining weight and becoming diabetes, is due to the bad diet or mistiming of the diet? Because now the mice are eating when they're not supposed to eat.
Right. And I think this is what's so fascinating about so much of your research, right? It's this idea that I think there's so many people that want you to believe it's like calories in, calories out, and all that matters is how much food do you eat, period. And that there's something very nice and easy to turn into an app about that idea. But the reality is that if our microbiome is active on a certain circadian rhythm, if our pancreas, is active on a certain circadian rhythm, if, our body's sort of activity levels follow a certain circadian rhythm, it feels absurd to think that it wouldn't matter. And I think it is so cool that you thought to ask that question, felt like it needed to be asked. Why don't you talk about what you found?
Yeah, so to just step back, because you brought up that a calorie is a calorie is a calorie. But the point is, it's not, if you simplify it. For example, in your office, there are, say, 100 employees coming to work. And an employee is an employee is an employee. Doesn't matter.
Which is crazy.
Doesn't matter when they show up, right? Wrong. Because if your security guy doesn't show up at the right time to unlock the gate, then nobody else can get in. And similarly, so that's why the timing does matter in every aspect of our life. Even your best friend, if he or she comes and knocks on your door at 2 o'clock in the morning, that person will never be a best friend again.
Or at least you receive them very differently.
Very different. So that's why healthy food at the wrong time can be junk. That was the idea. So then we took these mice, and then they're all born from the same parents in the same room. They had the same gut microbiome. One group got to eat whenever they wanted, just like 10,000 other experiments done. And then the other group was given food only for 8 hours. And it was not a magic number, 8 hours. We decided 8 hours because mice actually eat the same number of calories as the mice within 8 hours as the mice that have access to food 24 hours.
Right. And making that an isocaloric experiment feels important.
Yeah. Because unless you equalize calories and the quality of food, you can't make an interpretation from timing. Yeah. So to our surprise, the mice that were eating within 8 hours were completely healthy. And they didn't look like the obese diabetic mice with high cholesterol and fatty liver as the mice that ate the same diet throughout 24 hours.
So this is, I think, just absolutely fascinating. And I think our listeners are going to be saying, wait, what did he just say? So I want to say it again. If you eat the exact same food, just as much, same quality, but over 8 hours versus spread out over 24, doing it in 8 hours resulted in less disease than doing it over 24.
Yes.
Okay,
For
so
mice.
that was my next question. Mice. I am not a mouse. Does this apply to me?
Yeah, so let's get back to here, mouse. And then, this was the first experiment. It was very surprising and shocking. So I had to repeat it 2-3 times. And then we did it 8 hours, 9 hours, 10 hours. And we figured out that mice can eat within 8 to 10 hours and they can be healthy. One point is these mice were getting really unhealthy diet, like 60% calories from fat and 20% from really simple sugar, which will be equivalent to us eating all of our calories from nachos, ice cream. Okay. So in real life, very few people would eat that kind of food.
Although, doesn't that kind of sound like the standard American diet to you? Or you think it's maps to something worse than that?
No, it's worse.
Okay.
Because the standard American diet is around 35 to 40% fat.
Okay, that's helpful context.
Yeah.
So it's significantly worse.
It's the first experiment was 61 or 63% fat. And that too, unhealthy fat. It's not really...
But nonetheless, the sort of 8-hour eating window mice didn't develop these diseases, or they just developed them at a lower rate?
No, we did the experiment only for 18 weeks, which will be equivalent to maybe 8 to 10 years of human life. And these mice were young. So if we look at human population, suppose a young person is eating unhealthy food, but eating within a constant hours, then maybe for few years, maybe that person may not develop disease, but in long run, that person might develop disease. So we haven't done this experiment lifelong on this same bad diet.
Not on humans, but in the mice who were young over those 18 weeks, the ones that had access to food for 24 hours, they did develop a lot of disease. Yeah. So that's pretty profound.
That's very profound.
Yeah.
And in that case, then the question was, well, if you do it in humans, then what happens?
Yeah.
So I guess at that time, if I dial back, the paper was published in 2012, May or June. It was very difficult to publish that paper because the nutrition field thought calories are calories.
Yeah.
They were suspecting I must have made some mistake, and I have done this experiment 3 times. So it took us 2 years to publish that paper. And then I thought, that's it. I'm never going to work on it again.
Oh, no.
And then within 6 months, there are books out there, 8-hour diet, as if. So the point is, we did a study where we prevented disease and we prevented obesity. Prevention is not same as treatment. So for example, if I stop smoking, I am protected from, or my chance of getting lung cancer is reduced. But once I have lung cancer, it doesn't matter anymore. Even if I stop smoking, it's not going to cure me. It was a little embarrassing and shocking that people were now publishing this 8-hour diet book, and then there are bloggers and influencers. They're saying as if this is a thing in human. And there are some bogus clinical trial. I don't know how people could do a 6 months clinical trial in 3 months. There are actually bogus clinical trials that are cited in some of these books. And so that prompted me to think, okay, so we have to go back and do the right experiment. We fatten up the mice first and then put them in 8, 9, 10 hours. Or we ask, well, can mice just eat for 5 days in 8 hours and then have 2 days of cheat day? And what happens? So luckily, I had an awesome postdoc, Amandine Che, who came to lab, and she was ready to do all these experiments.
That's amazing.
And she had like 600 mice, and she tried all combinations of food, all combinations of timing. And the bottom line is, yes, if you fatten up the mice already have fatty liver disease, diabetes, obesity, etc., and then put them on 9 hours or 10 hours time-restricted eating, then mice will lose some weight and they will improve their health.
That's an incredibly important finding, that not only can this eating behavior prevent disease, but if you are already in a disease related to excess eating, following this diet does seem to show some effects of reversing those conditions. So there's a lot of hope out there because so many Americans are living with these conditions.
Whereas not only those conditions, in the same experiment, what we did, we actually put the mice on treadmill. And then we asked, can you exercise? And, we also asked them, we tested grip strength in mice, and mice had to do grip strength and then this treadmill. And then they had to run on a rotating drum to do the motor coordination. And what we found was once mice did time ratio eating for several weeks, and then all three factors improved. Their motor coordination was improved, so they could stay on a rotating drum, so they could be the circus mice. They can do all this stuff. And why this is important is motor coordination is a very complex phenomena. Mice have to visually or based on their feet, the tactile input has to go to the brain to process how fast the drum is rotating. And then the brain has to send the right command to the hand and leg to make sure that they actually step with the right speed, not to fall off the drum. So in that way, it actually showed that the effect is even much bigger beyond the body. It's inside the brain. So that was exciting. And then the second exciting thing was, if you look at most weight loss study and nutrition weight loss study, it's given that when you lose weight or anything that prevents you from gaining too much weight, that also impairs your muscle function. People who quickly lose weight, they actually lose a lot of muscle. And that's why people who are taking this new GLP-1 receptor drugs, they lose a lot of weight. Some of that is muscle loss. So their athletic performance deteriorates. So then we had the question, well, these mice are losing weight and not gaining weight. How is their athletic performance and muscle strength? So that's why we did those studies. And then what we found to our surprise was mice on time-restricted feeding actually gain muscle mass. And they retain that increased muscle mass late into their middle age. So we have done this experiment now to the equivalent of humans living to 50s. And, I'm selfish, so I did that just to see. And then we also put them on treadmill, and to our surprise, these mice that are eating unhealthy diet, actually in this experiment, they were eating, I think, 45% fat, slightly more unhealthy than the average American diet. Mm-hmm. But they actually outrun mice that eat healthy diet, but whenever they want. Because see, mice that eat healthy diet, they still nibble a little bit. 15% of their food they eat during daytime in the middle of their sleep.
Okay, so that's fascinating. So an unhealthy diet restricted to 8 hours a day seems to be more geroprotective than a healthy diet sort of eaten round the clock.
I won't go to that extent because it's only in mouse.
And then in mice.
In mice.
In mice.
And also, we took it to equivalent of mouse year of 50.
Sure.
Partly what you said is true. So now
yeah, so I'd love it if we could jump from mice to people. What do we know in people?
So in people, the challenge is people actually eat very randomly. A few years ago, when we're trying to start human experiments, we didn't know when people eat because just one day of food record is not sufficient to figure out when they eat and how consistent is their eating. Because in mouse experiment, we have also seen, we means other people in the field, they have done very careful experiment where they feed mice, but then they change their light-dark cycle by 8 hours or 6 hours. So as if the mice are going from one time zone to another time zone, even within the same week. So in that case, the mice change their eating pattern from one day to another. And those mice are also more prone to metabolic disease and liver disease. So along that line, somebody may be eating, say, between 8 a.m. and 4 p.m. today, 8 hours. And tomorrow that person may be eating from noon to 8 p.m., also 8 hours. And then day after tomorrow may come back to 8 a.m. to 4 p.m. A standard nutrition science student would take the average of this window and say, this person is eating 8 hours window, so it should be fine. But no, that's not fine because the consistency is important.
Right. So that says that it's not merely about consolidating your eating window, but it's about doing it at a consistent circadian phase.
Yeah. When we monitor people, and we have to monitor for 2 to 3 weeks using our app, My Circadian Clock. When we did that in the first study, we had 156 people. They had to log everything they ate or drank within 3 weeks. Log means they just had to take a picture of food or drink, whatever they were doing. And then we would look at the picture and decide whether it looks like water, then we'll say, no, it's not a calorie containing food. Or if it was black coffee or diet soda, then we did not consider them as food. But if we put just the food and the timing of food, then what we found was an average person was likely to eat within 14 hours, 45 minutes window. If we consider all the eating that happens within 3 weeks, then that's 14 hours, 45 minutes. Less than 10% of people actually ate within 12 hours or less. This was in 2015. So this was long before intermittent fasting or time-restricted eating was popular. So less than 10% were eating in 12 hours or less. We're not talking about even 10 hours or 8 hours. That's the data. And then meanwhile, people try to go back to large-scale data collected through Enhance, which is a massive data collection process, happens every 2 years. Nearly 2,000 people are interviewed about their food habit for 1 or 2 days. This Enhanced data is absolutely never reliable for determining eating duration or eating pattern. Anyone self-reflects their own life. If they randomly take 2 days, that's not going to represent their life for the year. Forget about projecting for next 5 years, 7 years, or 10 years. So far, unfortunately, there is no other data collection that have gone beyond, say, a few hundred people. But all the data collections, that data that have been published, dozens to hundreds of people, they come to the same conclusion that we are more likely to eat more randomly, and a lot of us actually eat all of our food in a window that's at least larger than 12 hours.
Okay, so most people are eating over the course of 14, 15 hours, which you could kind of see it. That's like if you have breakfast at 8 a.m., 7 a.m., then you're finishing eating in that 9, 10 p.m. window, which I think we all know loads of people who do that if we don't do that ourselves. What do we know about the harm of doing that versus if those people got into that 8-hour window or even 10?
Most of the time when we talk to people say that they eat within 10 hours. And then if we ask, well, what time you eat breakfast, they will say, well, I eat breakfast at 9 o'clock. Mm-hmm. And then if you ask more carefully, okay, so you wake up at 6 and you're eating breakfast at 9, there's nothing in between? They'll say, no. And actually, this is a real conversation I had with a professor a few days ago. I said, no, I don't eat anything. I said, okay, so what do you do then? No, I go to the gym. I said, so you go to the gym, empty stomach, and do workout and come back? Yes, I do empty stomach. And if I'm a little low in energy, then maybe I'll have half a glass of electrolyte. That's fine. And then he said, and after I finish my workout, I have a protein shake. I said, but that has calories. He said, no, it's protein. Of course, he's not a nutrition or biological science professor. He's
okay. So I'm trying to play this out my own schedule. Water doesn't count when you talk about this window. Okay, great. So
black coffee doesn't count.
Black coffee doesn't count. So calories. So we're literally talking about calories in any form. Calories should happen inside of 12 hours.
Yeah. So the bottom line is this. So for example, suppose I eat or drink anything that has 5 grams of sugar. So let's go back one step. Suppose you decide to bleed me to death and take all my blood. You'll find only 5 liters of blood, and you'll have less than 5 grams of sugar because my fasting blood sugar is around 90 to 100 milligram per deciliter. So only 5 grams of sugar, that's what is circulating in my blood. That means when I take just 1 gram of sugar and my stomach immediately absorbs that and sends to the blood circulation, so then my blood sugar will go up to 120 from 100. And then it'll wake up. So once instead of water, if I'm drinking even with 1 or 2 grams of sugar, it's waking up my stomach to do its work, that is to absorb nutrient, send it to liver, because everything goes through liver. The liver junction sees, there is something coming in, and decides whether to use some of it. And then it touches the pancreas. Pancreas wakes up, makes insulin. Insulin goes and unlocks the door in muscle and many other organs. So just by drinking or eating something that has 1 or 2 or 3 grams of just carbohydrate, simple carbohydrate, you are waking up the entire village to do the work.
Okay, so this is like a fascinating way to put this into perspective. So there's about 5 grams of sugar. And for context, what could I eat that's about 5 grams of sugar? That's like
1 teaspoon of sugar. That's
1 teaspoon. Okay, so very little. We're talking about less than half an apple.
Yeah.
And that is going to have about the amount of sugar that's in my entire blood. And we know, because we've seen, CGM data and whatnot, that my blood sugar is not actually going to double.
No.
Instead, I'm waking up the whole apparatus of deal with sugar to keep blood sugar stable. And once I've woken up the village, as you said, they're up.
Yep.
They're doing their thing, fast broken. To help us really understand this point, why is that a bad thing? When you call it waking up the village, sounds bad, but does the village go right back to sleep?
Yeah, so I'm just giving the analogy, but then we don't stop at half an apple.
Sure.
So we're talking about now actually what happens when village wakes up. So for example, insulin receptor gets engaged, and that will trigger mTOR cascade, and then mTOR will phosphorylate, among other things, some of the clock components, and that will also can likely trigger resetting of the clock in some cells.
Right, so this is the important point that we started with. So somehow, waking up the village tells your whole body that it's actually a different time. Than it thought, and your circadian rhythm shifts. Why is that bad?
Because the clock gets confused. It's almost like a jet lag. So just imagine when you fly from here to California, you're changing the time zone by 3 hours. And just that 3 hours wreaks havoc on some people. And we feel it because it affects our sleep-wake cycle. Bad thing is we don't actually feel the clock in our gut. Right? In most cases, we don't feel how
right, because
bad
there
it is.
isn't something as like painful as I can't fall asleep when I want to, the way we feel it with sleep.
Yeah.
But what I think is so fascinating about your research is you're saying that secretly, that exact same snack, even if it's a bad for you snack, is going to have very different damaging effects to my liver, to my metabolic health, simply based on whether or not my body was in a circadian phase in which it was prepared to receive food.
Yeah, so that's one aspect. Then the other aspect is, suppose I have gone through 10 hours of fasting. I stopped, say, eating at 6 p.m. Then this is 4 o'clock in the morning. I woke up to catch a plane, and then I decide to eat something. In the early morning, that long line next to the coffee shop, people are having their cappuccino. After maybe 8 to 9 hours of fasting, my liver is barely starting to make some ketone bodies. Just barely. The process is just starting. And then that cup of coffee with cream and sugar that I really need before I get on the plane puts a sledgehammer on the ketone making mechanism. So that's another aspect that happens. It's not only clock. It also happens to our body's own ability to produce these ketone bodies during long fast that has many benefits for our brain, for our heart, and also it has some anti-inflammatory benefits. So the story goes on and on and on because what we are dealing with is 3 different things. One is the fasting is breaking. So the fasting related pathways that are important for ketone formation, or maybe autophagy, somebody has gone through a lot of fasting, those are stopping. And then second, circadian clock is getting confused whether it's on or off. And the third thing is the body was actually not ready for eating food. Although we are saying that the body will process food the same way, it doesn't. It actually doesn't absorb food the same way, it cannot process it. And for example, if I'm eating that food at 4 o'clock in the morning, a big meal, then my stomach is not ready to digest and my intestine is not ready to move that digested food down the tube. So
I think there's an important practical takeaway here. In that first hour that I'm up, my body is not ready. I haven't sort of begun the preparatory processes to receive food. So we've heard that an 8-hour eating window might be ideal, and that eating window should be at a consistent time, but it actually also matters what that time is.
Yeah.
So what time of day, when to when, should I optimally plan my 8-hour window?
Okay, let's go back, put all this together.
Sure.
Because we talked about light, we talked about sleep. So actually, our day begins the night before.
Of course.
That's why the first thing is try to go to bed at a consistent time and be in bed for 8 hours so that you can get your restorative 6.5 to 7.5 hours of sleep. Then after waking up, wait for an hour or two so that your cortisol, the stress hormone, is not too high, your melatonin is not halfway down, so both of them are down in 1 to 2 hours because both of them are not good friends for our food. So that after 1 or 2 hours, again, just like going to bed at a consistent time, breaking your fast or breakfast at a consistent time is important for the clock. And then after you break your fast, so that's 1 to 2 hours after waking up, then you count 8, 9, 10 or maximum 12 hours window for your food. Because if you go beyond 12 hours, then your last meal becomes within 3 hours of going to bed, which is also bad. So that's why the maximum allowable window is 12, because if you think about a teenager or a 10-year-old, they may not be able to do 8 hours, but they can easily eat within 12 hours.
So I like that. That's actually fairly user-friendly. So it's, at least an hour after you wake up through no later than 3 hours before you're going to bed. So that's sort of 4 hours lost to padding on either side. If you're going to give, say, 7 hours to sleep, you're already, at 11. So then not a ton of buffer to kind of find that 12 hours in the middle where you're eating. And that actually feels doable.
Yeah, it's doable. It's only a few things. All the bad things happen after sunset. So between 6 p.m. and midnight, that's the challenging time because we evolved as social animal. We want to socialize. That's why it becomes very difficult to stay away from food for 3 hours before bedtime. And that's where having the mindset and coming up with some tricks to avoid food and enjoy maybe some sparkling water will be the way to adopt time-restricted eating and to improve health.
Amazing. Well, I found this incredibly interesting, and I imagine our listeners will as well. So thank you so much again for being here with us today.
Thank you so much. Have a perfect circadian day.